Hello, my friend, and welcome in this new recording. In case you don't know me, my name is Emmanuel, and yeah, in this channel I talk about programmation in general, but also I try to make some tutorials about what I'm currently working on. And the video we have today is going to be about the thumbnail generation system that I'm using when I am to build a new thumbnail for a YouTube video. By the way, sorry, I'm still using this pretty crappy webcam. I mentioned, I think, in the last video that I wanted to try to connect my camera, a Fujifilm X-T4 camera, and I wanted to try to use that as a webcam. So I actually ordered USB 3 cable to do that. So we have it here, a nice 5 meters long USB 3 cable, because my computer is actually behind the door that you can see behind me, so pretty far away from my actual desktop here. I need about 5 meters of cable whenever I want to connect something. So the screen, for instance, are using 5 meters HDMI cables. But for USB, that doesn't work so well. I tried that, and it seems that that's too long. You don't have a proper signal from the camera. Sometimes it's detected, sometimes it's not, and when it's detected, you can't even display anything. It's not going to work. Just showing a black screen. Probably, I think, because you don't have enough power due to the length of the cable, so you're losing power, and the signal strength is not good enough. So back to square one. I have another option that I'm going to try, which is called active cables. Actually, I didn't know this existed, but I've been investigating, obviously. So you can actually have some of those cable with some kind of amplifier integrated into the cable, and yeah, I just ordered one of those. Should arrive in a couple of days, and meanwhile we're stuck with this webcam. Anyway, maybe we should get back to the topic of the recording, right? So yes, about this thumbnail generator system. What can I say first? Okay, so actually I should probably make a complete tutorial on how to use this tool someday, but for now let's just try to focus on the new feature that I have introduced lately. The first idea I had was to try to provide some way to generate gradients, gradient images. So you would, for instance, move from one color to another color linearly to generate an image. I'm not sure this is clearly explained like that, but you could go from red to blue, and you would have a smooth transition between those 2 points. So you need coordinates, 2D coordinates for your points, obviously, and then you kind of feel the surface with the transition of the colors progressively between those 2 points. You could also have gradients that are radial gradients, so starting from a single center point, the further you go away, when you reach given the radius, you have another target color. So you start from the center and you go towards the outside circle, and you change the color progressively again. So if you provide very small transition for your colors, this can, I think, produce pretty interesting effects if you want to such smooth transition for backgrounds, or yeah, mostly for backgrounds actually. So yeah, the idea was to try to provide that, but I didn't do it. Actually, before I even started to work on that, I decided it was more important to refactor the mechanism I was using to generate the outlines around the the faces I was using on my thumbnails. So for instance, I can show you a couple of those. So this is my folder where I store everything concerning those YouTube recordings and thumbnails and everything. So where do I have that? That's the input folder, and we have the outputs where I have the generated thumbnails. So if you take, for instance, the last one is this one, I believe. And so you have this outline effect here around your face, or actually you could apply that to any different element that you have on this image, I think. So to generate this outline, first I was using an edge detection mechanism in Pillow, but the outline itself was a bit jaggy and not very clear, so I decided it was a good idea to try to use what I had implemented, in fact, in the previous tutorial. If you have seen that, it was this one concerning the background removal, and at some point, yeah, I was experimenting with expanding the subject mask, and that's really what I was doing, displaying some kind of area around the subject. So using this distance computation mechanism, you can get more precise results than what we had with the edge detections. So yeah, I basically wanted to replicate what I was doing here in the thumbnail generator itself, and that's why I have provided now this apply outline. We can maybe have a look at the thumbnail generator here. As a reminder, in fact, this is part of the Nerve project, so available online on GitHub, and so you can probably have a try if you want to. And I have now this apply outline, which is going to use this distance computation. I don't think it's necessary that I go into the details, but you start with an image and you are providing the contour size in number of pixels, so giving you the size that you want to use to draw this outline or contour if you want, and also the contour color. And then it's going to use the alpha masking from your image here to figure out what is the part that is the foreground and what is to be discarded, actually. And then it draws this outline around the foreground, and we use that whenever we have an outline size provided for a given element. So it can really be any kind of element, in fact. So let's say, for instance, actually this is not the last one. The last one was this one, and you see I have this Qt image, which is a PNG image, and I think I can show you where we have that. So that's going to be in the inputs and logos, I think. And it's this one, right? This one is not good because it's actually not transparent. So I'm using this one, logo free. And I could decide to draw an outline around this image. Let's try that. So that's going to be, is it this one? So let's see, output, no, NVL 17. Let me just find the appropriate file first, NVL 17, okay. And yeah, we have the logo here. And if I were to say, for instance, outline size, let's say I want 15 pixels. That should work, or maybe I don't provide pixel and it's supposed to be just number. I'm quite sure. Let's see, because this is another kind of mechanism that I have. Yeah, it's just supposed to be a number for now. Okay, good. So if I just state that, it's going to use the default outline color, which is white, but I could decide to change that to outline color. Let's say I want this to be completely red with some transparency maybe. So let's say half transparent. And now I can do something like NvP gen thumb, and it's the NVL 017. I don't need to make a copy normally, but let's just make a copy to be safe. Let's call that original. And if I just execute this command now, I should have regenerated my image, and you have the outline here half transparent. Maybe half transparent is a bit too transparent, we can barely see it, so let's just make it completely opaque. And now you have it. All right, so this is the outline at play of this function, which is working just fine so far. Anyway, the idea was still to try to generate gradients, and to do that I started to think, okay, the easiest option I see would be to try to use SVG. To try to use SVG, I found a few packages for Python, but the most interesting to me was this DrawSVG package. Let's maybe check the home page. So this is DrawSVG 2, and if you check this page, you will see that it's really flexible. Actually, you can do, I mean, with SVG, basically, you can do a lot of things, and this one is providing access to most of the SVG elements. So to me, it seems that I could use that to do, well, very interesting stuff. You can draw text around a path, for instance. I mean, following a path. You can draw partial shapes, use transparency. With the path anyway, you can really build any kind of shape you want. So yes, this is definitely going to be very flexible, and generating gradients of course is possible, and you can even do animation like this one. So we'll get back to this one. Problem is, if you want to have support for instance, to generate animation, or in fact just to be able to convert a generated SVG document to PNG or another raster format, you need to install the full version of this package, and it's explained at the end. So to install the full feature version, you need to use this DrawSVG all as package. But when you do that, you actually introduce a dependency on the K-roll, which is a C++ library in the end. So this one is not going to be installed by any Python package. So you need to install that manually. On Ubuntu, it's easy. macOS, easy also. But on Windows, you have to use Anaconda or Miniconda or whatever to get this K-roll package. I mean, K-roll module, mostly. And yeah, point is, I don't want to use Anaconda myself. I don't have Anaconda installed on my computers, none of them. It's not really that I think it's a bad thing to use it. It's just that I am kind of always looking for trying to handle the challenges myself. So In a case like that, if I see that I need the Cairo library, I would find a way to build Cairo myself. So this is what I did, and this is now part of the NvP project itself. So you can, in fact, use the builder for Cairo, which is, let me find that, NvP builder. We have Cairo builder here. Currently, yeah, I didn't provide the implementation for Linux because I would expect this one to be fairly easy to provide. For now, I'm only working on Windows, but eventually this could be extended. But we have the full implementation needed for compilation on Windows. And I think I mentioned that here. Yes, the starting point I was using is this GitHub repository here. And if you go there, the repository itself is very minimal. It's just providing you with a script with everything you need to build Cairo on Windows, following indications from I think, yeah, from this page here, which are the official indication actually from the cairographics.org website. So it's telling you that, yeah, you need MSys, DevStudio, curl. Do you need curl? I'm not sure. Whatever. So if you start from there, you will see that in this script you're going to first compile all the needed dependencies. So you're going to download everything first, so Cairo, Pixman, libpng, zlib, and even FreeType. And so you start with libpng, then where is zlib? Whatever. Funny, I mean, zlib is built at the same time. Well, I didn't read this part very carefully because anyway, I already have zlib and libpng compiled with the NvP environment, so I have those dependencies available. The only thing that I really had to introduce was a builder for this Pixman library. So you will also find another one for this one, so Pixman here. Again, I'm only providing the Windows implementation for now. I didn't really check the Linux implementation. And yeah, it's building fine. And you can install your Pixman libraries this way, which is then used as an input for Cairo, because if you check Cairo, you will see that I'm retrieving Pixman for the Pixman folder, and I'm linking to that library. And I'm also linking to the other dependencies that I have. And since I'm linking to FreeType static library, and in FreeType I actually integrated the Brotli and Half-Buzz dependencies, I also need to link to those libraries, otherwise you get missing symbols. But anyway, using this builder, there's not much you need to do to build the thing. It's just a command like NvP build libs Cairo. On Windows, it's going to use the MSVC compiler by default. Oh, that's one thing. It's only working with MSVC, I believe. So you have a check here ensuring that this is the MSVC compiler. I actually did not even try with CLang, so maybe it's working. I'm pretty sure it will not work. You need to modify the make files themselves, because the make files here are referencing CL as a compiler, so will not work with CLang. Okay, almost 20 minutes already. That's going to be way too long. I'm going to have to cut this, but never mind. So yeah, we got Cairo built, but oh yeah, another interesting change I did in the process is when you have to download the sources for Cairo. In fact, let me just check that. It's in the NvP in the config file, here we define the come on. So the Cairo library, and it's going to download this package as the source package to do the compilation. And it was in fact the first case for me where I needed to get a ThumbGen package on Windows. So on Linux it was not really a problem, but if you try to decompress this on Windows, you will eventually reach this this unzip package function in the tools component, and the command here X-T4 is not working on Windows. I mean, with the version of tar that I happen to be using at least, it was not working. So I decided to update a little bit this process, and now we're using this tar file package directly inside Python, and this is working perfectly. So, and you don't even need to execute an external process anymore, because this is just keeping everything inside Python, so that's cool. Alright, what else? So this was the builder that I have already shown. It's pretty complex because, as you can see, I had to patch a lot of stuff to get all the dependencies taken into account properly. But yeah, no, not really a big deal. Except maybe I should mention that here, you see those replacement here. This is needed because on Windows I'm using I think it's GNU Make. Let's see, in tools, Windows, or just Make. What is this exactly? Yes, that's a GNU Make. But this Make executable here doesn't really support executing external commands. I mean, maybe it's supporting a few of them. It's supporting at least echo, but I guess, yeah, it's supposed to support the commands that are available on Windows when you execute the prompt or something like that. But typically mkdir is not available, so this one is going to fail. And it's not even very clear in the indication. So I had to investigate a little bit to figure out. It's just telling you that there's a syntax error in your make file, and it's, well, killing the process. But yeah, trying a few different things, I eventually figured out that it was this makedir command which was not working. So I'm basically just ignoring that, and then I am preparing the build folders myself. Like that. If you just need to create this, you need to create the release folder and the Win32 folder, so you just create that in one call, and that's all you need. That's all what was done by those commands here. But another thing then is this for command here. This also you have to replace because it's not working, and this one is really in fact executed at the end of the compilation process to tell you, okay, you successfully built Cairo. Now you need to copy this list of header files into the destination that you want to store the package as a whole. But yeah, I already knew which header files I was going to copy anyway, so yeah, I have a list here, and you don't need this to be outputted. And apart from that, I think there's not much more to mention concerning this builder. What else? Yeah, I made a dedicated function with the install files. No big deal. And then trying to do some initial test with DrawSVG package. So as mentioned on the installation page, you need to have this this package here in your Python environment. So I have added that in my media env. Yeah, I mean, it's pretty easy also to add stuff in an existing Python environment. So for instance, if I wanted to add something, I could do media and like that, and anything that would not be installed in the environment. Oh yeah, it's actually reinstalling my module. Anything you had in your configuration, so in the media and definition, at the top one, okay. If you had a new package here, it would be installed. So yeah, at first I was trying without the module, and to test this, I have in fact provided a test function that you can call directly in the thumb generator module. So this one, this DrawSVG test. So I could do something like NvP. I need to check what you're going to use for the command itself. I mean, for the script. It's the opposite. So that's the name of the script you want to execute, and it's going to call this component with this first argument and more argument then if you want to. So if I just do that, it's going to not work. Draw is not defined. Oh yeah, I know. I move that away eventually. So this is something I'm not going to discuss here. So let's just pretend that I already add this one, and we'll come back to this SVG generator file, but definitely the next time, not this time. Let's just re-add this one, and if we try again, except that I am in nerve land. Well, never mind. And if you run that, boom. This is executing the function that we have here. And this one is basically a copy of what we have available on the is it here? I think it could be here. Yes, at the one generating this this movie animation here, and eventually I am saving an MP4 file myself. So I took the code that we have here, and I don't think I've changed anything, in fact, except for the last commands here where I uncommented that to generate this orbit MP4. But yeah, first I was doing that without the K-roll DLL file in the environment. So, whoops. So without this file, and if you do that without the file, obviously it's not working because you cannot rasterize the SVG that you generated just before. And I think this is something I actually mentioned also. That's the command I created, okay. So that's a function to generate the movie, and if you run that, you get an error like this one. Blah blah blah, because yeah, the module was missing. So that's where I added this module, and then as you can see, there's no error anymore. And if we go in the corresponding folder, we have this Orbit MP4. Very small, but actually it's still a fully valid MP4 if my computer, okay. Pretty low resolution because SVG canvas itself was very small, but that's something you can increase if you want to generate video files like that. But yeah, probably not something I would do very often myself. I don't know. And yes, I think this is it. From this point, in fact, we can start using DrawSVG to generate any kind of SVG content, and in fact you can then rasterize this content into a PNG or even an in-memory image, and those images I could then use in the thumbnail generation process to display either a background if I'm just generating a simple gradient image, but you could in fact produce much more complex stuff. And in fact, this is something I started to do, but yeah, we're going to discuss that in the next recording because I don't want this to be a very long video again. Just a couple of notes as inputs to find additional information on how to use DrawSVG. I'm basically using those two pages only for now. So there's a README page, which is one now. Not this one. I mean, this one also is the index page. So you have here a more in-depth description of each of the available SVG element. So that's probably a good start also. And there is a README where you have a few examples. So we already use one of those examples to do the movie generation, but you have more examples that are very interesting also, like how to use gradients, for instance. So this is a typical transition effect that I would like to be able to use as a background for my thumbnails. And okay, so this is it. Currently, you can use that already with Nerve Proj, but as I said, we'll make another recording and we'll provide a more in-depth tutorial on how to generate thumbnails with this system. Anyway, thank you very much for watching, and if you have any question, let me know in the comments, and see you next time. And meanwhile, happy coding. Bye bye.